All right, this is Pre-Algebra, lesson 12.5, Congruence and Similarity. Congruence and Similarity. And sorry I'm a little bit late getting this posted, but unfortunately the recording in class today somehow got goofed up trying to save it, and so I'm redoing the lesson. So that's why I'm a little bit late getting it posted. But here we go. All right, congruence and similarity. So first off, congruent polygons. Congruent polygons. All right, there are two aspects to congruent polygons. All corresponding angles are congruent. Congruent. That means they're exactly the same size and shape. 30-degree angle, 30-degree angle, 27-degree angle, 27-degree angle, etc. Each corresponding angle of one polygon is congruent to the corresponding angle of the other polygon. And then the other part of congruent polygons is that all corresponding sides are congruent. All corresponding sides are congruent, which again means that the sides are also the same length. The sides are the same length. So all corresponding angles are congruent, all corresponding sides are congruent. Here's what we mean by congruent polygons. I'm going to come back up there in red, put a parentheses and say the same size and shape. Same size and shape. And therefore that means all corresponding angles are congruent, all corresponding sides are congruent. All right, let's take a look at our example here. So here are two congruent triangles. These triangles are exactly the same size and the same shape, okay? And although they can be reflected or mirrored, and that's actually what's going on. This triangle is really the reflection of this triangle. And so you know how you look in a mirror and things are opposite. Your left is your right is your left. That's what happened. They're mirror images, but they're still congruent because they're both still the same size and the same shape. All right, so let's take a look at the way that we signify congruent triangles. So we've got triangle ABC. Here's your congruent symbol, and then triangle ZYX. Now, the lettering and the order of the lettering is on purpose. There's a method to that lettering. So let's start off with the angles. Remember, all corresponding angles are congruent. So I'm going to take my red and I'm going to write angle A. Notice A is the first letter listed. Now we can use the shortcut because we know where angle A is. So if you look at the first triangle there, I'm going to take my purple. You don't need to do this at home, but I'm going to illustrate angle A, right? It's that angle right there made up of those two sides, right? That's angle A. All right, and we can use the shortcut because there's only one angle. Now, which angle is angle A congruent to on the other triangle? Well, watch. See the way it's lettered, triangle ABC, and we did angle A first? That means it's going to be congruent to angle Z. So if everything's right with the world, if we look at the angles, angle A should look the same size as angle Z, and indeed they do. And we're going to take our red and we're going to do a 1 arc mark for angle A and a 1 arc mark for angle Z. They are congruent angles. If we were to take a protractor and measure them, I don't know, it looks like they're about 120 degrees, maybe 130, something like that, 140. But they're both the same amount of degrees. Okay? Secondly, then, I would then go next to the second letter. So the left-hand side, second letter is angle B. And angle B would be congruent to what angle? And everybody in class, almost everybody was able to see that it's angle Y, right? So I'm going to go up to angle B on the left triangle and put 2 arc marks. And I'm going to go up to angle Y on the right triangle and put 2 arc marks. Angle B is congruent to angle Y. And of course, looking at the lettering, angle then C has to be congruent to angle, and hopefully you're thinking angle X. And so we'll finish off with 3 arc marks for C and for X. Okay? All right, now not only that, but our sides are congruent. Now, I pre-marked the sides of the triangles. But we can do the same thing with the sides we just did with the angles. So watch, I'm going to use my green now, and I'm going to say line segment AB. That's one side of the left triangle. Notice how AB are the first two letters. So guess what side AB is going to be congruent to? And I could say YZ or ZY, but because the Z is first and the Y is second, I'm going to say line segment ZY. And sure enough, if you look at the triangles, isn't that the way they're marked? Look at side AB, and it's one arc mark, or one mark. And look at side ZY, and it's one mark. All right? Now I'm going to go to the second two letters, right? Side BC, which is line segment BC. So which side, according to the lettering, would it be congruent to? And hopefully you say, oh, that's clear, that's obvious. Side YX, right? Line segment YX. The second two there. And that's exactly the way that goes. Second two there. All right. So what would the third one be? I usually go from the third back to the first because I'm going in order. I'm going right to left. So I'm going to continue and then I got to go back to the beginning. So the last side is side CA. And it would be congruent to side, and hopefully you would say line segment XZ. Okay, notice all three angles are congruent to their corresponding angles, and all three sides are congruent to their corresponding sides, right? Okay, now let me show you one other thing here. I'm going to use my space. You don't need to do this, but let's suppose I had triangle here, and I'm going to go A, B, C. And let's suppose I had triangle here, and I'm going to go X, Y, Z, okay? And let's suppose they gave us some markings, and let's suppose they gave us a 1, 2, again, you don't, just watch, okay? You don't need to write this, 3. And so this one would be 1, and this one would be 2, and this one would be 3. And I could mark the sides, but I'm just going to do the angles because it's easier. All right, so watch. If I were going to say the two congruent triangles, let's suppose I used triangle ABC as the first triangle. Once I chose the lettering ABC, what then will be the lettering of the second triangle? So again, you have to make sure that the angles match and that the and it just so happens I picked it so the letters are the same. Bummer. Here, let me do it differently. Watch. Let's suppose I made this Q, R, V. All right. Because it was going to turn out the same way. All right. What would be the lettering of the second triangle? First is triangle ABC. How would you name the second one? Well, here's how I figured it out. One arc mark is the A. Two arc mark is the second to B. And the three arc mark is the third to C. So I have to follow that same pattern on my second triangle. Do you agree? Okay, so where's the one arc mark at angle V? Where's the 2 at R? And where's the 3 at Q? So it'd be V, R, Q. See how that goes? So that's for if you have to name the two congruent triangles. The other way is using the congruent triangles. But remember this, whenever you're using congruent triangles, the lettering will tell you a whole lot. You don't need a picture. So that's what happens here in this next example. So here in D, we're told that triangle PQR is congruent to triangle TSR. Okay, great. This should be an easy quiz or test question. What angle is congruent to angle Q? What angle is congruent to angle Q? Go ahead and answer that. What angle is congruent to angle 2? Pause if you need a little bit more time. All right, hopefully you said, hey, Q's in the middle and S is in the middle, so it's got to be angle S, right? See how easy that is? Let's do the same thing with our sides. Question number 2 here. What side is congruent to line segment ST? All right, it'll be a line segment. So again, take a moment. How would you write it? Which one goes with ST? So again, you look, okay, S to T, all right, Q to P, right? Line segment QP. That's the way that goes. All right, and so that's a common thing with congruent polygons. Now, I use triangles because it's easier. You don't have a ton of sides. But it can be a quadrilateral. It can be a pentagon, an octagon, a dodecagon. Again, corresponding angles would be congruent. Corresponding sides would be congruent. Remember, congruent, the same size and shape. Now let's get to our blue here, similar polygons. All right, similar are a little bit different than congruent. Similar polygons are an enlargement or reduction, right? It's an enlargement or a reduction of the original. You're either making it bigger or smaller. The original is going bigger or smaller. All right, let me show you an illustration down here at the bottom. I did this in class today, and I thought it was a good idea, so let me do it again. All right, so here is a quadrilateral, right? I drew a quadrilateral. I'm going to copy it. Let me paste it. Okay, there's an exact copy. Right now, these two quadrilaterals are congruent. They're exactly the same size and shape. All angles are congruent and all sides are congruent. Does it matter if it's spun? No. No. All angles are congruent to their corresponding one and all sides are congruent, right? Doesn't matter how it's spun. All right, let me get it back to regular orientation. Well, what is a similar triangle? Oh, now we have similar triangles, right? The one is larger than the other. Or I can go this way. Now I have similar triangles. The second happens to be now larger than the first. Now looking at them, what can you tell me about the angles of similar polygons? What can you tell me about the angles? For example, let's take a look at this angle right here and this angle right there. What do you think? Well, hopefully you say, hey, those look congruent. Here, I'll prove it to you. I'm going to take the shape, I'm going to move it right over top, and lo and behold, aren't those angles exactly the same size and shape? Yeah. Look at the top left angle. I'm going to line them up. Aren't they congruent, the exact same size and shape? Look at the top right angle. Aren't they congruent, the exact same size and shape? Look at the bottom right angle. Aren't they congruent, the exact same size and shape? Absolutely. So the angles are congruent, but what about the sides? For example, this side and this side. Well, they're not congruent, are they? So what are they? All right, let's go back and fill in the blanks. So similar triangles, all corresponding angles are congruent. That stays the same. Just showed you that, right? But all corresponding sides are proportional. Proportional. Let me real simply explain what that means. You take this and see if I can get away from the green. Good. Let me just, yep. Just give me the green. So, all right, let's see what will happen if I X that out. If I can get to my X. Okay, good. That's what I want. All right, so let's take a look. I'm going to actually make this second one a little bit bigger. So I want to illustrate here what's happening to the sides. It's about right. Okay. Now this makes it a little thicker too, but that's okay. I tried to make this about 2 times larger. So watch. What if this top side were a 10? What would this side be if it's 2 times the size? You get 20. So if this were like a 14, this would have to be a 28, right? 2 times. I don't know. Maybe this was a 24. This would have to be a 48. And let's do the other one backwards. Let's suppose this one were a 20. Let's go more than, that's got to be more than 20. If this were a 40, there we go. All right. Then this one would have to be half of it, or 20. Does that make sense? See, they're proportional. Look, double, 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 right? This one, that one, double. Or if you go the other way, halves. Doubles or halves. By the way, let me show you the proportion. Double. If I put the big one on the top and the little one on the bottom, or halves. If I put the little one on the top and the big one on the bottom. Either way, you get a true proportion. Doubles or halves. All right, that's a lot of writing there. Let me see if I can get rid of it all. Undo, 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 undo. That's a lot of undoing. All right, hang in there. I'm just going to undo it all, get rid of it, get it out of my way. All right, it's enough. Okay, so let's go through and write a few things. Wow, guess I undid a whole lot more. Okay, so corresponding angles are congruent, and corresponding sides are proportional. So let's go ahead and write the angles. So angle J is congruent to what angle? Again, we're going off the lettering, right? So it would be angle X. Angle J is congruent to angle X. Angle K is congruent to angle Y. And angle L is congruent to angle Z, right? But watch what we do with the sides now. Our sides, we have to make a proportion. And we can make the top all the first triangles and the bottoms all the second, or we can make the tops all the second and the bottom all the first. It's our choice, but it's got to match. All right, so I'm going to do this first triangle in green. So the first side is J to K. But proportions are numbers. Line segments are shapes. So I'm just going to write J to K. That means how long side JK is without the line segment symbol over top. This would be the shape, line segment JK, the actual line itself. But without the line segment symbol, it's how long is it? So JK. What's another side of our first triangle? KL. And what would be the third side? LJ. Now on the bottom, and I'll do the bottom in black, I'll do the second triangle in black. What side goes with side JK corresponds? Well, the length of X to Y. What length goes with the length of K to L? The length from Y to Z. And what length goes with the length from L to J? And hopefully you'd say Z to X. All right, so again, just a recap. I did the first on the top, and I put the second on the bottom, and I could have flip-flopped it. I could have had the second on the top and the first on the bottom. I'll show you how we're going to use that in just a moment here. So let's go to our next page. All right. All right, so here's a problem C. Let's suppose we've got two triangles, triangle ABC. Notice the symbol. That's the similar symbol. That means that the angles are congruent, but that the sides are proportional. And if you look at the triangles, don't they look that way? This one is a smaller version of that one. Okay? So the angles are congruent and the sides are proportional. Now they want us to find side LM. The way to find the side is to make a proportion. Okay? LM is right here, right? So we're going to make a proportion. Now we've done a chapter, I don't know, 4 chapters ago on proportions. Remember, you got a fraction on the left, an equal sign, and a fraction on the right. Do you guys remember where I always put the variable in my proportions? And hopefully you're thinking top left. So I'm going to put LM top left. All right, so here's what I'm going to do. I'm going to make my top the bottom triangle. Or if you want to think of it as the big triangle, right? And I'm going to use green. I'm going to make the bottoms the top triangle or the little triangle, right? I'm going by size. All right. Top and bottom may be confusing, right? I'm talking about top triangle, bottom triangle. All right. Okay. So what side goes with side LM? Well, you can do it two ways. Look back over here at the triangles. Here's LM, so what side has to go with it? BC, right? And so what is the value of B to C? It is a 6, so that's going to go in the bottom of our proportion. We have an LM on the top and a 6 on the bottom. Now, in these problems, we're given all the other sides. So I really can choose any sides I want. Sometimes I won't have all the sides I need. So I'd have to choose the side that goes with something else. Well, again, I'm back to my bottom triangle. Am I going to use the 15 or I'm going to use the 21? Well, thankfully, I have both of the other values, so I can use either one that I want. Let's use the 15. So if I put the 15 on the top, and what is the 15? Look, the 15 is the K to L. So therefore, it would go with what? The A to B. And what is the A to B on the other triangle? And you can see it's the 10, so I've got to put the 10 on the bottom. Okay, that's my proportion. Let me rewrite it so I can refresh your memory on how to how to finish it, how to solve it. So we have LM over 6 equals 15 over 10. All right, you remember how to move this? Things multiplied times a variable, you move by multiplying by the reciprocal. We're going to multiply the left by 6 over 1 and the right by 6 over 1, right? It's going to cause our 6's to divide out. We have now isolated our variable, haven't we? And hey, class, be careful. You've got some reducing here, although this one kind of works out nicely because 6 times 15 is 90. And what's 90 divided by 10? It is 9. And the length of our side LM is a 9 proportional. All right, that's how those go. Let me show you a couple more. The second one's a little tricky because they don't show us the triangles. We have to figure out which sides are proportional, which sides correspond. Okay? So it doesn't tell us. All right. Well, I know they want me to find PR. So P to R, I'm going to use an X, side X. All right, let's set up our proportion. Fraction bar equal fraction bar, right? Are you there? Fraction bar equal fraction bar. Okay. What do we put in the top left? What we're looking for. Okay, in this situation, the top is going to be the little triangle, right? Therefore, the bottom has to be the big. Now, you have to determine this side on this one goes with which side of the bigger one. And what the way you're going to determine it is which side is bigger, that one or that one. And hopefully you said the 16 is bigger than the P to R. The P to R is the smaller one. So therefore, you're going to use the smaller one. You're going to use the 46. That's a little tricky because these look pretty similar. And sometimes it won't be that bad. It'll be more obvious. Sometimes, too, this one isn't the case, but there's a right angle here. And then you'd know that you're dealing with hypotenuse or not the hypotenuse, okay? All right. Whoops. Let's go back. So let's go ahead and now finish our proportion. Now on this one, again, I got to go little on the top. So I'm going to use the red segment here. That makes it easier. It's in red. It's a 6. And what goes, which is the red segment of the big triangle, it's the 18. There's our proportion. X over 46 equals 6 over 18. X over 46 equals 6 over 18. Okay, now, I will have to tell you, this isn't the only way to do these. I think it's the easiest way. So again, you got to be careful to get the parts to correspond. So I chose the top to be the little triangle and the bottom to be the big, because what I was looking for was from the little triangle. I believe that's the easiest way to solve. All right, if you look at the bottom proportion, you're going to multiply both sides by 46, right? There is some reducing of this. A 46, let's do the 6 and the 18, right? That's a 3 on the bottom. It's the easiest way. And x equals 46 thirds. We're going to leave it like that. That's an exact answer. Okay? X equals 46 thirds. See, that's not a clear-cut answer, but that is the correct answer. Because for similar triangles, the sides are proportional, and those are similar triangles. Okay, one more. This is a very common looking drawing of similar triangles. Be careful here, because the bigger triangle is really has the little one inside the front of it. So I'm going to help you visualize this by separating them. Whoops, let's see if I can get it. There we go. Do you see that? So what do we have here? And I'll show you this in a minute, how this become important. We have Y, we have W, we have V. This is a right angle. And by the way, they share this common angle here, so that's congruent. And by the way, you're going to find whenever a triangle has two congruent angles, so not only is the front angle congruent, but the right angles are congruent, then the triangles are similar. They have two congruent angles. So be careful, we're using this little triangle and the big triangle. Okay? All right, let's set up our proportion. What are we looking for? X, Z. All right, let me clean things up here. Need a bigger eraser. XZ. Okay, I'm going to call that, let's call it A, because we have X's and Y's all over. Let's call it A, all right? You can call it ZX if you want, or XZ. Okay, so I'm going to put that on the top. So again, in this problem, which triangle is on the top, the little one or the big one? Well, it's the little, right? Now, what side on the big one goes with side XZ? Well, you've got to be able to see this part to get it correct, but it's the 26, right, which would be here. Okay, that's the corresponding side. Now, again, I have both values, so I can choose either one, the 24 or the 22. I'm going to use the 22 as this side of the small triangle, of the little. Now, what does the 22 go with the big? A lot of people make a mistake on this. Be careful. Look right here. Let me do this. I'll use a dotted line there. You know what a lot of people say to put on the bottom right here? 34. But do you see how the 22 is from here to here and the 34 is from there to there? So what really is the bottom side of that large triangle? And I hope you say 56. That's tricky, but I'm showing it to you so you'll remember it. Okay? And it's tricky, but I'm showing it to you so you remember it. Okay, and then you finish. Again, I'm going to just clean up because it's easier to show you how to finish. All right, things multiply times variable. You move by multiplying by the reciprocal. Multiply both sides by a 26 over 1. All right, we got our A isolated. And a little bit of reducing. Let's see. 56 is a 2 times 28. 22 is 2 times 11. Okay, the 2's are gone. And up, 28, 2 times 14. And 26, 2 times 13. And those 2's are gone. So what do we end up with? 11 times 13 over 14. All right, I'm using my calculator. And it looks like 143 over 14. All right, that's the value. That's the concept. All right, be careful with these, with the similar triangles, highly quizzable and testable questions. So you got to get those down, how to figure out your proportions. So be careful with tonight's homework. All right, it's page 517. 1 through 10, you don't need an original. No original for 1 through 10. Then do 21 through 24 normally, and then 28, 29, and we'll go over it tomorrow in class. All right, that's it. Have a great day. Hopefully I won't have a problem with getting this one recorded. All right, bye now.